As an introduction, let's explain about how Edureka works. Basically, Edureka is like online portal where they just give you mechanism, the leaders, the trainers, which can train you on the different latest technologies. And I'm also the one of the trainer from Edureka. We are mostly concentrating on the latest technologies, which can help people to learn something new, and they get something new content different from the documentation and other stuff. So that's the plan from the from Edureka. And a bit introduction about myself. I'm working as a team lead in one of the startup in Bangalore, currently staying near HSR layout, and I have an experience of around 6 years, and in that around 3 years in Kafka and other Hadoop big data technologies like Storm, Flume, SGFS, MapReduce. So those technologies I was working from last 2.5 years in the startup. Currently working in one of the product on in-house product for the application product management using big data and real-time streaming. So currently working on that, and so let's start. So this Kafka, this is what agenda we have. You guys can see the agenda, what we have agenda for today's. So guys, let's start. So this is the agenda for webinar today about Kafka. The first thing, why Kafka, why we need Kafka, $1 million question, why we need Kafka when we have so many messages, messaging queue or messaging application, and why we need Kafka. This is a ice-breaking thing when we should ask when we are entering in Kafka world. So second, what is Kafka architecture, and how Kafka is getting integrated with Hadoop, Spark, Storm, and there are companies who are all using Kafka, and some demo. Let's see, it's a big and then $1 million question on why we need Kafka. So Kafka, maybe you guys are aware of any messaging system, any JMS you guys have used in your previous work or in your current projects, like ActiveMQ or RabbitMQ, yeah, IBMMQ. Yes. These are the messaging queues. So the basic function of messaging queue is like you are using those messaging queue for inter-process communication. Mostly they store the messages for some time, and then there's consumers who are trying to consume those messages in an async mode. Mostly people are using for that purpose, but there is a limit. There's a limit, like for all the messaging queue, the number of messages what they can handle and how much parallelism they can provide when you are accessing, when you have high load on your system. Let's say, take example of one of the most social networking site, let's say Facebook or Twitter, where millions of users are tweeting every second. Every second there are so many messages, millions of messages are there every second. Then in those cases where you have such load, you do not have any messaging system where you can provide this storage and someone can analyze the system. So there's no messaging system which can work with online streaming. And the other part is throughput of those messaging queues, because they work mostly on G2E applications, and where you do not have that load, where your messaging queue will, because mostly people use for async purpose, for database purposes people are using, that do not have that much load. But when you start fetching for the real-time applications, then you get the load, and you have where you can verify your MQ, messaging queue. So in all such cases, you have a different solution altogether, Kafka. And the Kafka, best part with Kafka is Kafka provides 100% reliability to your messages, because there's nothing in memory. Everything is getting written to files. It's literally log files, all the messages at that speed with 1.2 or 1, you can say 2 milliseconds. Yes, in milliseconds, it is writing the messages and the consumers are consuming the messages. So it is a publish subscribe messaging queue, but with high throughput and highly scalable. We can add the scale without stopping the cluster. We can add new brokers. I'll tell you in the next slide like what is a broker and all. You can think like we can scale without making your site down. So you can keep on scaling up your Kafka and as per your load. If load is increasing, you can add more brokers and it will work. And it's simple, it is easy to scale, and throughput is high. It can consume millions of messages in 1 second. Yeah, this question, from Srivastav. Like how does it differ from Rabbit MQ? So performance-wise, Srivastav, I can show you in Gaurav like how performance-wise it is differ from Rabbit MQ, but you do not have distributed storage in Rabbit MQ, right? But Kafka provides you the distributed storage, where you can have, suppose there's heavy load and you are getting 100 Mbps, 100 messages per second, 100 MB per second. So then in that case, whatever storage you have, Rabbit MQ will not able to suffice on it because it has to install on single server. It cannot provide you distributed storage. But whereas Kafka can give you distributed storage, you can have multiple brokers and all the messages can be written to all the brokers. The messages can be written to multiple brokers, as well as the reliability. Suppose you're writing the messages to multiple brokers and one of the broker is going down, one of the server is going down, you have other servers where the same message is replicated, so you have the data. So there's no data loss at all. The data reliability is high. And the performance wise, I have one slide where I can show you the performance of Rabbit MQ and others, the performance wise. Gautam, Zookeeper, I'll cover Gautam. Let's because this is just introduction of the Kafka. We are getting in touch with this. So Gaurav, this is what I was talking about, the performance and the throughput of your Rabbit MQ and the Kafka. You can see that Rabbit MQ, the first one, let's say, bring one highlighter. This is the bar of Rabbit MQ, the performance of the Rabbit MQ. And you can see this Rabbit MQ performance, it is this one, the second line in the graph, right? When messages are reaching more than your 10,000 or 20,000 messages, your Rabbit MQ is not working, the throughput is not there with Rabbit MQ. You can see the messages. You're able to see this graph, Srivastav. What it does, Kafka provides you this batching concept. So all the messages what producer is writing, basically it will write in batch, and then we can dump the entire batch at a single site towards in the system, in the storage space. I'll cover it now, these things, how batching is happening and other things. But this is just a part of the introduction. Let's move to introduction part. This is the exactly thing what even Gaurav was asking, and this is the first thing which you will have in your doubt, like when you're talking about queue, how it is different from the other JMS application or any async message queue protocol. So just I discussed those things like scalability and throughput, which we are not getting from any other messaging queues, and the way the other messaging queue are performing. The normal queue application is like messaging system works like there are two models on which the messaging works. There is one which called as publish subscribe, where there are publishers which are publishing the messages, and there can be n number of subscribers who are subscribing to those messages and they are consuming it. Whereas this works like broadcast to all, where publisher will publish the message and it will be broadcasted to all of them. Whereas there is a queue systems. In queue systems, there's a single queue or multiple queues, for example, and we are pushing to one layer, and there is one consumer which can consume the messages. It will not be broadcasted to all. These are two basic models on which how your messaging system works. And if you want to compare most of the messaging systems, so what Kafka is having better than other messaging system is like Kafka has partitioning. So what is partitioning, replication, and partitioning is I'll tell in the other slides. The partition, you can think at the moment, you can understand like when you're pushing some load or pushing some messages to the Kafka divides those messages in terms of files. Those files are called as partitions. Under our layer, the label is called as topic. Under the topic, you divide those messages in partitions. Like for one message, I'm writing to partition 1, the other message to partition 3, other message to partition 4. So for example, if I've created 4 partitions, it means I'm writing to 4 different log files in Kafka Broker. So the number of partitioning is giving me more parallelism. Means if there are 4 files, means 4 different consumers can consume this at the same time. 4 files consumer can consume at the same time. One second, guys, I have one question. Niranjan is asking like, do you mean one message is written to all partitions? Niranjan, is not written to all partition. A message is written to only single partition. It depends then the replication of that message, how many replication you are expecting from that messages. But your replication should be greater than your number of brokers, because you cannot replicate the same message in the same broker. So it will be written to some other. Optimal number of partitions. Uma, the number of partition, it totally depends. When you configure your broker, your Kafka in your dev environment, you need to optimize, you need to configure it accordingly, because in case if you want to use with 6 consumers, then you have to give something like 6. But it totally depends the number of brokers you have and how much load you have. So you need to find out optimal configuration in your dev environment with changing the number of partitions and that, because the performance moves like with some, when you increase the partitions, it increases the performance and it reaches to a certain layer, and after that it starts decreasing. So totally this parallelism depends on your cluster size. I hope I answer your question. Is there any algorithm used when writing to partitions? There's no need of any algorithm there. There's no need of an algorithm. I hope you are asking about round robin and other algorithms. There is a partition key. So producer will use the partition key, and as per the partition key, they will write in the multiple brokers. Has Kafka integration with popular framework? Chitresh, Spring and Kafka, you are missing 2 things. You can connect Kafka with, Kafka has many client APIs. Java is also one of the client API with Kafka, and you can use any of these Kafka. You can use any of the client application to connect it with Kafka. So you can connect this Spring also. So I was explaining like how it is different. So you can always think like how it is different from other messaging application. You need to think about partitioning, how it is writing the messages into logs. Second thing, replication, how Kafka is giving you data reliability, how it is writing the same messages in multiple, how it is replicating the messages, or how it is writing the message in different brokers, different partitions. And this is a good solution compared to any other applications because of being fault tolerance and your replication as well as your partitioning. Fault tolerance, how it is providing the fault tolerance, because if in your cluster you have multiple brokers, and brokers means servers here. So in case if one of the server is going down or broker is going down, you have multiple other brokers available where you have your data. So for any time your data is available. So this is the performance chart which they have people at the LinkedIn, because Kafka was developed initially at the LinkedIn, and they prepared this chart when they were developing this thing, your new Kafka API. So they developed this, they compared the performance with single user, multiple batch size. Omar, we'll take the question at the end, but still Zookeeper will manage the brokers. So this is the comparison chart of the performance of all the things. So it says like RabbitMQ. RabbitMQ is the one of the most used or widely used messaging queue application. But you can see like this also has limit after 20K messages, and even the documentation of RabbitMQ says that it supports 20K messages. But beyond that, you can see that Kafka can support with a batch of, can go to millions, 2 million, 3 million records also at the same time. Even I have seen in our system, the dev environment, we were able to push 100 MB of data. Even because our message size was used, we were pushing something around 6 KB messages used, because it was having used data. And for those, because of that, we were having 100 MB per second. That kind of streaming we were getting with Kafka. And second, consumer, that's what I was talking about. Producer is someone who is writing the messages into the logs. Then we have Kafka consumer performance. The consumer performance, you can see the difference. The RabbitMQ initially with a small number of messages starts well, and after that it slowly decreases the performance. Whereas the Kafka is quite consistent. We are quite consistent with your performance. How it is achieving this thing, I'll explain in Kafka. So this is the next one, like what are the features, 5 important features of Kafka. First thing, high throughput, support million of messages with modest hardware. The best part of Kafka is Kafka works on your commodity hardware. It doesn't require any enterprise hardware for giving you such performance. It can work on normal commodity hardware with normal hard disk. You can connect multiple hard disks in different servers, and you can collect and make Kafka cluster with that. So it works on modest hardware, and it can give you millions of messages. It can process millions of messages in 1 second. Scalability, highly scalable, distributed system with no downtime. highly scalable, because without making the system down, we can add more brokers to the system with a small configuration change, because all Kafka is talking to Kafka brokers are talking to Zookeeper, and Zookeeper has the configuration for number of brokers. You can configure new broker host name, and you can provide the port, and you can add the broker in the cluster, because there is no broker to broker communication is there, but when you add it, once they are added, after that it will start. In broker list you need to update. Second, replication. By default, like you want to replicate your messages, because in case if you have 4 brokers, for example 4 or 6 brokers, and you want your message to be replicated 3 times, you can increase the replication of your message. You can set the replication factor for your message. But in any case, your replication factor should not be greater than number of brokers. You can understand why. Because you have brokers 3, it cannot replicate more than 4. There's no sense of replicating 4th message. There's no point of having a message in the same broker twice. Third, durability. Provide support for persistence of messages to disk, which can, and this is something which is like it is continuously writing the messages to the disk. So because of this, it provides the durability. Writing to the disk, yes, it is writing to the IO. It is doing IO, and it is writing to file system. So someone should ask this question, like this is one of the important design, or you can say architecture of Kafka. Ki how come if any application which is doing 2000, which is handling millions of messages at the 1 second, and it is doing 2 million IOs at 1 second, how it is handling this IO? Because IO is wait, right? IO wait is a latency. It will always add the latency, and it will slow down your performance. Okay, this is something which like there is a kernel level concept which is called as zero copy, or you can also say as like serializing. Any idea about zero copy? Yeah, I think you guys have idea of zero copy. So exactly, this Kafka uses a concept of zero copy, where you're skipping the file channels and you're directly writing data to sockets. Suppose Zookeeper is down, Kafka will also down or not. You have Zookeeper cluster. You do not have one Zookeeper in cluster. You have multiple Zookeepers. So this is a zero copy, where like normal application, how it writes, it generally it goes to application buffer, then to the socket buffer, and then it writes it. So if the socket to socket starts communicating directly using transfer to method or file channel, they can skip the all context switching. So that way it will be a bit faster. So they are using this thing concept, as well as there is like concept of serializing, not serializing, sequential access. So sequential access means in hard disk concept, like because you are pushing messages to the file or to the disk, I should say, in sequential manner, where suppose someone is asking for message number X, what kernel does, it right click, it knows like someone is asking for X, so next time it is going to ask this plus this. So what Kafka does, Kafka has one like fetch, how much fetch size is they are looking for. The consumer has this power to select, give the fetch size. Okay, like I need next 10 MB, I need next 20 MB. So what Kafka does, it takes next 20 MB, and the meantime it puts this in memory. So for consumers, they are not reading directly from the storage, but they are taking from the memory. This is how it provides that 1.2 millisecond latency. With 1 or 2 millisecond latency, they can read a single message. Doing IOs, they're reading, they're pushing message to the storage, and then consumers are reading from the storage. This is how they are achieving this durability as well as high speed. Streaming processing, the same logic is working here also. Stream processing is required when you have application the real world who are using Kafka just for stream processing. For example, Twitter, I took Twitter or LinkedIn. When somebody is tweeting something on Twitter and they want to analyze the emotions, how people are talking about this. Suppose a movie released and there are so many people who are tweeting about the movie, and Twitter want to analyze like how people are talking about this movie. So in real time, they need to analyze the tweets. They need to analyze all the tweets. So they need something, an integration device. They need some device which can push data from the Twitter API. The Twitter exposes some API where they can give you the tweets in the real time. And you need something which can push to your application which is analyzing the data. For example, you are using Storm, or maybe you are using some machine learning algorithm to find the emotional analysis of those tweets. So this is how Kafka can support you, where this is like huge number of millions of messages are tweeting. At the same time, it is providing that input to your application. Your application should be able to handle that load and analyze the messages. That's how they will generate this tab, basically like what is tweeting, what is trending on Twitter in the real time. So this is what streaming feature of Kafka. Data loss. Kafka ensures zero data loss in the real time because everything they are writing to disk, so there is no data loss there. And they have retention period, configurable retention period. So by default, it will be stored for 1 week. But in case you want your data to be stored more than 1 week, you can configure that and you can use it. But you should have that much space where you can store data which is coming such a high speed for more than 1 week or 2 weeks. But by default, it's stored in the Kafka is storing for 1 week. You can store it for further also. So for that 1 week, any of the consumer can consume your data. It is highly available and there's no data. Kafka advantages over other application or other messaging. Kafka, we can easily 100 or 1000 of messages in 1 second. It is millions of messages per second, as we have seen in LinkedIn, because LinkedIn is certified like they can process 2 million messages or 100 MB with single producer. And when they start this producer into multiple threads, like three producer, then they have something like 170 MB messages and 4 million messages per second. But the message size is small, some bytes, 100 bytes, but they can process these many messages per second. Where is the data stored, and or something file system or something else? Yes, Venkatesh, it is storing in the file system. Kafka writes files. Those files are called as partition files. The number of partitions you are defining, it is writing to those partition files. And Kafka provides a configuration path where you can store you can give your file path also, where I want my partition file to be written, in which disk I want it to be written. With Kafka, we can easily, and the cluster can be expanded with no downtime, making Kafka highly scalable. The best use, whenever you think like in future, the way we are increasing the load on the system, in future we may need more storage, where we need more brokers. So you can add more brokers to the server. Considering the number of messages it can process, please throw some light on how replication occurs. Sure, Dinesh, I'll explain. Messages are replicated, which provides reliability and durability. Yes, how it is replicating, I'll tell you. Fault tolerant and scalable. I told you like how it is fault tolerant and scalable. So this is like someone is asking like some basic line of what is Kafka. So Kafka, simple, we can, in simple words, you can say like Kafka is nothing but Kafka is your publish subscribe messaging system, or you can also say as like Kafka is distributed, partitioned, replicated, and commit log system, because ultimately it is writing everything in log. It is doing everything writing to log. This is what Kafka documentation says, like it is distributed, it is partitioned, it is replicated, and it is a log service. Or in simple terms, you can say like it's a publish subscribe messaging system. Broker and partition is logical and physical. It's physical, Harish. You have servers. The servers are nothing but brokers. You have files. Those files are nothing but partition. Developed a LinkedIn corporation. Yes, it was developed a LinkedIn. Provides solution to handle all activity stream data. This is the main use why they developed it, and how that's why it is able to handle that streaming messages so well. It is able to cope up with the real-time messaging. What kind of information shared between the brokers? Kafka using only SDFS file system or any other system also support. For replication, there will be there's communication between the brokers. And the other thing you're asking, Kafka is not using SDFS. Kafka is not using SDFS. Kafka is a different application or project in your Hadoop ecosystem. Please provide solution to handle all activity stream data. Fully supported in Hadoop platform. Why it is fully supported? Because it can cope up with, it has so many client APIs written in Python, your Scala, and your Java, and many other languages. So you can use any of the client API and you can connect to Kafka. But I will explain like what is a Kafka client, what do you mean by Kafka client, and how to write Kafka producer and consumers. Partition real-time consumption across cluster of machines. This is what how they are handling the partition, how they are handling the logs between multiple machines. Provide a mechanism for parallel load into Hadoop. So this is how you can say like when you want data to write in SDFS, does Kafka process data stored in, I was coming to this point, Arvind, provide mechanism parallel load into Hadoop. Yes, when your like LinkedIn, how LinkedIn is, what LinkedIn has done, LinkedIn has developed one tool, they call that as a Canvas tool. That Canvas tool, they are connecting with your Kafka. Kafka is taking data from the online application, their logs, their metrics, and all the data they are getting to Kafka. And then Kafka, after that Kafka, they have written one MapReduce program. That MapReduce program is called as Canvas, and which takes data from Kafka and stores into SDFS for further processing and for the graphing system, for the representation of metrics, for the representation of other log and errors. It is available, Canvas application also, you can see on GitHub and all. The application is available, how they have done this MapReduce program. So let's go a bit deep and Kafka architecture. So all those questions like whether what is producer, consumer. So these all are here. Producer, consumer, and broker use CAMUS. There is a CAMUS, Canvas. Yeah, perfect. So this is your Kafka architecture. This Kafka architecture says like producer, consumer, and broker use Zookeeper to share data and state with each other. So if you see like components in Kafka, so I can divide those components in three parts. Like there is one producer who is producing the messages. There are consumers. This is producers who are continuously publishing the messages. There are consumer groups who are consuming the messages. And in between you have your broker, or you can say server. In case you like this is first time you're listening word broker, you can call it server also. But for Kafka world, it is broker. So there's a broker, producer, producers, and consumers. Fine. Now in this example, they have only one broker, a single broker, and this Kafka broker, they have one label. That label is called as topic. So suppose for same type of messages, you can push to one topic, one label, and you can push to that topic. And the consumer group, they can read messages assigned for the particular topic. The complete consumer group is assigned or dedicated for a single topic. They can consume the messages from the same topic. You getting this point? This is because this is the concept of programmatically it's a bit complex, so we have to write and understand. But logically, how they are connecting and how they're publishing, that's what will go in broker detail, in the bit detail for the broker. But overall, this is the thing, the producer who are continuously publishing the messaging, and then you can understand there's a black box, that is broker. Under some topic they are pushing the messages, and then they are consumer who is subscribed for the messages, and they are consuming the messages for the further processing. Now let's go in bit detail for broker part, like what is broker and how it is handling this thing. So broker, you can see now they increase this broker into three parts. So we have three brokers, right? There are three brokers, and there's producer and there is consumer. So you can see there are P0, R1, P2, R1, P0, P1, R1, R2, right? So this P0 is nothing but these are the partition files. Like in broker 1, they have created one file like P0. In the broker 2, they have one more file for partition 2, and same thing, they have replicated those data on other partitions, P0 in broker 1 and broker 2, and the other partition files are replicated in the other servers. These all producer, consumer, and your broker, they all have to communicate through Zookeeper. Zookeeper is one who is managing this complete, or who is coordinating with complete cluster and their components. Like for example, when producer is pushing masses, producer has to understand like to which broker I have to push message. So if you have n number of brokers, there is a broker leader, or you can say the broker leader, and the other rest of them are followers. The leader one who will take the message from the producer and who will have the initial copy, and the followers are the one who will replicate it. Getting this is how it is replicating. There's leader who will take the message from the producer, and how producer will get the address of leader from Zookeeper. They will communicate with Zookeeper, and Zookeeper will tell, okay, this is the leader for me. So then producer will communicate with the leader, and leader will write one copy to itself in P0, and it will say like, okay, replicate to broker 1 and broker 3. You replicate this copy. This is how replication happens. It's a bit different from the way name node and data node happens. The replication in SDFS happened. We can take 1 minute or something. You can guys try to understand this concept. This is something which is like What is leader? A leader, in case if you have multiple brokers in your cluster, Kafka cluster, then producer has to he cannot go. A producer cannot go and talk to all the brokers at that time. He needs someone whom he can directly give the message. Okay, you write it, because it's happening in such a fast manner. Need only one address. That one is nothing but your leader. No, Niranjan, can broker 1 be leader of P0 and P2? See, P0 is partition 1, your first partition. So partition 1, the whoever is selecting, right, this totally depends on your zookeeper. It will randomly select any one of the broker as a leader. So it has nothing to do with P0 and P2, the partition files. It totally depends while creating the topic, how many partitions you have defined. I'll explain using the command how we are creating the partition, and I'll define how we are creating the partitions. Can you explain how the partition is replicated, and in the event one broker goes down, what happens to data in that file? So Dagar, once how the partition is replicated, you have the same message and it will be written to different brokers. That broker communication will happen. And regarding your next question, what is that? Once one of the broker goes down, what happens to that data? If one of the broker goes down, it can come up after some time, because you have other brokers where you have your data safe. Yes, I'll take these all three questions at the end of the session. Can Kafka consume read random message from Kafka broker? Yeah, it can, because it requires, it stores the offset. So as per the offset, they can read from anywhere, That was your question, Pari. So it can read, yes, it can read, because it maintains the offset, and from that offset it can read it. It will manage the offset in Zookeeper. All the consumers will manage their offset in Zookeeper. Kafka is the client server architecture. So Harish, it's not exactly you can say client server architecture, but whoever is talking to Kafka is your client. So Kafka has exposed some API using Java API, because Kafka is basically written in Scala. So they have exposed API, but in Java also they have exposed API in Python, C, C++, REST, and other web services also. So all you can use any of those APIs and you can connect to Kafka. Karan, I will summarize once I'm done with session. Is it okay for you? Because others are we are in middle of that. So next, Kafka core components. So these are the 4 components which we're talking about. There is one topic. It's a category. It's a category of feed to which messages are published. So as we were showing in diagram, right, in the picture, this is a topic. This is a topic. You can think this topic as a folder. In case if we are writing, partition is a file for us where we are writing the log, then topic name is the folder of that partition where you have that partition. Producer, someone who is publishing the messages. Consumer, who is consuming the messages. And broker, who is handling all the producer and consumer, where you have you are storing your messages. So Kafka topic. Of Kafka topic, you can say for each topic we have this complete set of 3. They all are single topic. They're single topic. Under a single topic, you can think topic is a folder. So we have created one folder in Kafka broker, and inside the broker we have created multiple files: partition 0 file, partition 1 file, partition 2 files. Now whenever this particular broker is receiving the messages, what they are doing, they are writing the messages to the partition from the back. You can say queue kind of structure at the back. They are always appending at the back. So file, right, file, we start writing into the file is always ending at the last of the file. The new records are getting appended to the last of the file. So it maintains the offset of the file. So when a consumer is coming, it will start reading from 1, 2, 3. You can see the numbers. You can think these numbers are nothing but offset. Okay, and this is the point which I can explain. Each partition basically contains an ordered, immutable sequence of messages. Why it is immutable? Any Java guy can explain this concept, why it is immutable. Because in case if it is mutable, so it will be tough to modify to maintain the sequence of the messages. You may lose the data. So that's why it is immutable. Sequence of messages where each message has a sequential ID. So you can think one is one message. second some other message, third some other message. So these are the messages stored and they have the sequential ID. So how consumer will work here? Consumer will say like, I want to read the message 1, read it, and they will update in what? Zookeeper, okay, I have read message 1. So next time whenever the same thread will come, it will read the value from Zookeeper. Okay, I have last time I read 1, so now I will read 2. So like that it will maintain. Why do we need multiple partition? Parallelism, Shiva. When you can think a normal Java or any programming language, if you have multiple threads or multiple processes trying to access the same file, obviously they have to wait. They have to wait because when someone is accessing the file, other has to wait for if someone has opened the file in read-write mode. So because we are always writing or reading the file, so others has to wait. When you're writing to multiple files, all multiple threads can access the same file or modify the same file at the same time. So it provides you the parallelism, right? So to partition are generally sequential, thereby reducing the number of hard disk seeks. That's what the sequential, as I explained, like when you have writing the messages data in sequential, someone is accessing X or 1, your database or file system can take the next n number of records and it can push it. Few more questions. If so, then every partition is stored in different machine. No, they all are stored on the same machine, but you can write them on separate disks. You can maintain multiple disks. It means Zookeeper maintain log of reading messages. So what memory size of Zookeeper? You can there is no constraint. You can use good memory for the Zookeeper. Generally, people will use 64 MB. You can use any good memory for Zookeeper because it generally, if you have 4 threads, so it generally maintains only one value, the offset value, and some configuration. Kafka producers, so this a lot to cover. Okay, Kafka producers. So these are the producers, you can say like Kafka producers and clusters. Application publish messages to the topic, the cluster. So same thing, we have one topic and all producers are bind to that topic and they will keep on pushing messages to those topics. So your producer, this producer is nothing but your client. You can write for Kafka, it is a producer, but they have exposed their APIs, so you can use those APIs and you can write your own producer. While writing messages, it is also possible to attach a key with the message. Same key will arrive the same partition. So key is like, for example, for a particular topic, you created 5 partitions, and you want whenever you are pushing the message, you want like for this particular key, this message should go to partition 1, this message should go to partition 2, this message should go to partition 3. So in that case, when you're writing the message to the topic, you need to provide your key also. In case you are not providing your partition key, then Kafka uses its own partition logic that says like for first 10 minutes write to one partition, the next 10 minutes write to one partition. So this is a way like Kafka handles the partitions. It handles the partition key. In case if you're not providing, if you're providing, it will take the partition key whatever you're providing, and it will take hash of that partition key modulus number of partitions. So this is a normal logic of selecting each partition in one time. This partition key modulus hash, the hash of partition key modulus number of partitions. So they can get number of partition and you can use it. Doesn't wait for acknowledgement from the Kafka cluster. Yes, that's because if they will wait for the Kafka cluster, then they will be in sync. They call as Kafka supports both mode, sync mode and async mode. Synchronized mode where they have to wait for the acknowledgement. Async mode where they will not wait for any acknowledgement from the cluster. They just keep on pushing the messages. So you can understand why there will be difference of speed performance in sync mode and async mode. When you need acknowledgement properly in your producer side, then you can go with sync mode. There's a configuration change and producer.type. Then you can, if you want like there's no need of acknowledgement, just keep on pushing messages to the Kafka. You can go with async mode. Kafka consumers, same thing. Consumers like application subscribe and consume messages from brokers and Kafka clusters. So you have Kafka clusters where multiple partitions are there, log files are there, and you have consumers where want to subscribe the message. So all consumer has to be labeled under one group or you can say like field where there a single type of consumers where they're trying to read the same type of message, you can combine them in a single group. They will read from a single topic. So during consumption of messages from a topic, a consumer group can be configured with multiple consumers. When consumer group will come in picture, like when you have multiple topics or you can have multiple brokers and you want like this consumer should read only this one and other consumer should read only that one, then in that case you can create multiple consumer groups depending on like what kind of data you want those groups to read. You can club your consumer threads and you can call them consumer group. Each consumer or consumer read message from unique subset of partition in each topic they subscribe to. This is the one of the thing, like if you in case in one particular consumer group you have 3 consumers or 4 consumers, every consumer will read a unique subset. They will not read the replicated messages or duplicate messages, because there is no duplicate in the same broker and they are trying to read from the same broker. Messages with the same key arrives at the same consumer. It supports both queuing. This is how you can say switching happens between the Kafka cluster. In case if you have multiple brokers or multiple partition in your system and you are trying to read with 3 consumers, then what they will do, they can assign one partition to all the consumer threads. For example, 3 partition P0, P1, P2, 3 consumers C1, C0, C2, C0, C1, C2. Then P0 will talk to C1, and C1 will read always from P1. C1 will read from P1, and C2 will read from P2. It's like there's a equal parallelism kind of thing. One will talk to one. You should have always your number of thread. Either it should not be less than number of partition. It should be always equal to. Equal to is the best combination, and you can have more. Because if it is less, then is a problem. Maybe one single will start pushing to do different things. Supports both queuing and public subscribe. This Kafka consumers must have to maintain the number of messages consumed. So number of messages they are consuming. So a consumer itself will maintain that record, like how many messages they have consumed. So where there you can verify like whether we have read all the messages or not. So this is a Kafka broker, but in bit detail. Broker 1 topic. So this is like you can see there are multiple brokers in your cluster, and every broker has like they have only one topic. Topic 1 is the name of your topic, and you have replication of 3. So partition 3. So there's one partition P0 in broker 1, partition P1 in broker 2, and partition P3 in broker 3. So you have 2 sets of producer which they are writing to all the brokers. You can see there. Producer is writing to P0 also, P1 also, and P2 also. Even the second producer is writing to all the producers. And if you have set of 3 consumers, every consumer is associated with one partition. Right? That's why consumer 1 is connected to partition 0. Second one is partition 1, and third one is partition 3. Each server in the let's see the theory part. A server is in the cluster is called broker. Handle hundreds of MB of write for producer and the reads from the consumers. Same thing for the how it is pushing and how the others are reading. How retain all the messages. That's what I told. Like they have, by default they will have retention period of 1 week. They can retain your messages for 1 week, and you can configure for n number of days. Any published message is available for consumption for configured n days. Then thereafter it will be discarded. So this is like when you are pushing the messages. If your config retention period is 3 days or 5 days, 6 days, it will be there for 6 days. After 6 days, you can delete it, or it will be deleted by Kafka itself for saving the space. But during the 6 days, any consumer can consume this message. This message is always available for consumption. Works like a queue if consumer instance belong to the same consumer group, else works like publish subscribe. For example, if you have multiple, instead of using multiple consumers, if you take as a one single consumer and one single producer, it will work like a normal queue, normal traditional queue. Same, they're trying to show in detail like how producer is pushing multiple messages. One message is going to one partition, the other message is going to other partition, and there's one producer who is pushing only to one messaging. So this works like normal thing, normal traditional queue, where you do not have the system. Does the lead broker act as a load balancer as well as do we need to separate load balancer for the cluster? So that we don't need load balancer because you are providing your partition key in your producer. When you're providing a partition key handle the load, like it is not pushing all the load to a single partition file. Your partition key has to be like it is writing to all the partitions. So the load will not always go to one single partition file. And the other thing is like a lead. Yes, lead is the one who will be like the first one who would receive the messages. Could you explain the difference between the queue and publish subscribe? Karan, I have covered this, but I'll explain it. This is the part which mentioned how the Kafka read message from the disk so faster. Okay. Guys, we'll cover these two questions once because we are running out of time and we need to show some hands-on also so that you guys have some idea of Kafka hands-on also. So this is the one of the tool which we are using, which LinkedIn is using for connecting to SDFS. Whatever the data they are taking from the sites, so what kind of data you expect like Kafka can handle. So you can think like from site they are taking the matrix like what is the CPU says, what was their memory size or the heap size, what are the how many cycles they have done. So they were printing all GC related details, they are printing all their hardware or system related details, system application matrix and system matrix. So all those matrices are getting inserted in your Kafka queue, and after that they are using and they are analyzing those metrics and whatever the alert system they have, they're using for the alert system and other purpose, but in the real time, because you can understand the importance of alert system real time here, because in any case if one of the server is going down or system is going down or it is going out of memory, so they know this thing like where memory is reaching 80%, memory is reaching 90%, so they can get action like okay, this in future like in next 1 hour or 2 hours the system will go down, so they can handle the alert mechanism. So here this real-time processing matters. Like if your tool or real-time monitoring system is not giving you the metrics in the real time, there's no use of those monitoring tools, because you need to monitor your application in the real time. So this is one of the use for how they are using, how they are processing the other messages also. Log integration also, people will use Kafka for log integration. In a server they have a number of logs and they want a single place in SDFS where they can see all the logs, where they can process or analyze their logs. So what they will do, they can use any Flume or some other tool to fetch the logs from the server and then Kafka for pushing it to SDFS. That's what LinkedIn is also using. Kafka is one of the use. Hands-on in the Kafka webinar. So this is something like, guys, when we go in bit detail, so we need to understand these things in bit detail, and also the producer API, how to write a producer, how to write a consumer, how we can write simple and high-level consumers. So how do we know load has suddenly increased? Which monitoring tool is used? Yes, Harish, that's what they, we don't know. I have not seen the KMS code, but this is working for them. A single MapReduce job is taking all the data from Kafka and they're writing into SDFS. Maybe as depend on their size, they must be running multiple mappers for that. But surely I do not have deeper understanding of KMS. But this is one of the use of Kafka, how the LinkedIn is using Kafka. That's why I put that inside. How Kafka consumer will know offset of the message when you want to read random message? They start from 0. They have the configuration Pari, for the offset, whether they have to read the offset from the smallest, then they will start with the 0, or the largest, then all the latest. When they go to the subscribe, the latest one, they'll start reading from them. So it depends how you configure your consumer, it will start taking the offset accordingly. And once they have taken in the startup time, whatever the offset value they have taken, after that they will push the offset value to the zookeeper. And once they are coming for reading the new message, then they will ask the zookeeper, what was my last offset? They will take the offset value from zookeeper, and then they will go to that partition for that particular offset. And there was one question from Karan. What was that? Queue and publish subscribe. The queue and publish subscribe is like when you're pushing the messages, and the messages are available for all the consumer groups. They all can access the message at the same time. And whereas queue, you have one single consumer, one who is using the consumer, the other consumer will consume some other message. The same message is not available for all. Guys, so can we go for Kafka practical kind? Let's see like Kafka cluster and all those things. I missed the part Kafka read the message from the disk so faster. Okay, regarding the Kafka disk so faster, that concept is like you have a zero copy concept in your kernel, which is like you can skip the file channels and you can directly do the socket to socket copying. You can read there's one very good article from IVM on zero copy, and you can also find this zero copy concept, like how zero copy works. So basically Kafka uses that zero copy concept to make it more faster, even though they're using disk. And second thing, they are using sequential access. So sequential access means your system knows, your application knows if someone is trying to access offset X value, then sure, for next time they're gonna read X plus Y. So they read X plus Y from the disk, and they put those data in memory. So all consumers can consume from that memory. So this is how they maintain the sequential access. So guys, I'm using Sandbox. The Sandbox plus SDP Hortonworks distribution. Which Sandbox is this? So that's what I'm explaining. This is from Hortonworks. I'm using currently. So where I have almost everything configured. You can see currently, but other I'm using just Kafka for the demo purpose. So you can see the Kafka package directory structure. I can show you. So you can see like this is Kafka distributed directory structure. So there's like contrib where you people can contribute and you can push your own things or your changes. Then there is config file, config directory, like any other. So config, you can see like there are 4 major properties, configuration properties. One, file, which is related to all the properties related to producer. There's something which is related to consumer properties. There is your Kafka server properties, and then you have zookeeper properties. I'm ignoring this log4j and other properties files. So these are the 4 properties file which you should know when you're starting or bringing up your own cluster. So these are the 4 property file which are must. You should change it and modify it. So we'll learn once we are in the session, main session, like how to configure and what to configure in this property files. Next, we'll go to bin. So they have for simplification purpose, they have created so many scripts for monitoring the Kafka, for doing anything on Kafka. So basically, let's create one Kafka topic. So you can see there's command script like which says like Kafka topic.sh. So this is the script file they have written for anything if you want to do related to topics. So I can like create. This is the command. This is the option which you need to provide to him, like what you want to do. Zookeeper, the address of the zookeeper, because they have to talk to zookeeper. All the producers has to talk to zookeeper. So this is the zookeeper, and because I have everything installed on the same system, so I can say like my zookeeper is running on the local host and the port is like 2181. And then as usual for this topic, what is my replication factor? Because I have only one broker, so I'm giving 1 because I have only one broker. If in case if I have multiple brokers, I would have given 2, 3 something. Depends on number of brokers I have. This is the partitions. So same reason, one single sub broker. So there's no point of giving. You can configure it, depends on your cluster, and you can give multiple. And then you are giving your topic and topic name. So this is Edureka test 1. For example, I just created something like this. So it says like it created Edureka test 1. Thanks. It's created. So we'll go to Kafka, see like where it created this thing, and then we'll start pushing some messages to Kafka, and we can see like whether it's reading those messages or not, and how the partition topics will look like. You can ignore this tool for the timing because we are just talking about. So guys, as you see, you can see like there I have mentioned the directory name is Kafka log directory. So we are in the Kafka log directory. So just now I created one topic with name Edureka test. So you can see this is the one, Edureka test 1. This is my topic name, whatever topic name I have given. This is folder size. And then because I have given partition as 1, so when I have given partition as 1, the next 0 is telling me that this is the first partition. In case, for example, you can see something personal thing. So in case I have created 4 topics, then it go like Flume, Sync, testing 0, 1, 2, 3. So I have 4 partitions there. So this 0, 1, 2, 3 is telling me the partition number. Let's go inside Edureka. This file, there's something like index file, and there's something like log file. This log file is nothing but this is my partition file. And inside that there is index. This index, which is there, you will maintain the offset and other important data, or you can say inode kind of thing in file system, right? So how you can read the file from middle and something. So all that related information your Kafka stores in index file. So this is what because currently I'm using Hortonworks Sandbox. So this is what my broker host name is there, broker name is there, and then the port number for my producer. There is 66667 for the producer. For next thing is like on what topic we are reading. So in case what topic we are reading, we have created one topic like this is the topic which you are pushing messages. So hyphen topic and the topic name. So this is easy thing you can understand, like what console you are running, console producer, and then broker list, then your host name of the broker, and then the port number and what topic. So we are entering. So I'm like hi. The same time I can run one more window to see like, so guys, you can see like earlier the file size was 0, right? So now this file size is increased and it is like 90. So all the messages which I was pushing using Kafka producer went to my partition file, and then you can see like your Kafka consumer is able to show those messages which I was pushing through producer, right? You can see, right? This you can see the difference when they're pushing and they're reading is like very less. Initially it was there and then it is very less. So guys, this is one basic example of how we are pushing in messages. So this producer and consumer scripts, this is nothing but this is a basic script for just to verifying your cluster and just to show like how to which topic we are writing, how topic is maintained, how partitions are maintained. So that's it, guys. That's it. In the next when we go for the complete session, we'll see like bit detail all the producer and the consumer APIs. We'll try to write a few producer for ourselves. We'll try to see like how we can write producer for Flume and how we can integrate with other, for example, Storm, other application integration with other application, how we can write consumers. So, and this is what is there in detail. We'll go each and everything in detail. So the questions you can shoot, and then please provide your feedback. How do we get these PPT slides? Yeah, Edureka will share those PPT, and even they will share the recording also. Don't worry, they will share the recording as well as PPT. So thanks, guys. It was good session, good questions from you all. Are you teaching this course? Yes. How many modules in the regular course? Basically, there are 4 modules in the course. For the first is like basic, which should be something similar to today, but bit more about how the comparison and other things and stuff. And then the basic thing. The second module will go in bit detail of the Kafka architecture, Kafka code, Kafka. And then, yes, it is a 2 weeks course. And then the third, will integration with other stuffs. And the fourth module. And third, we are going with writing producer and consumer, and fourth is integration with other Hadoop ecosystems. Karan, you can talk to Edureka. Okay, you can talk to Edureka person. Okay. 4 days, but the classes are like they will happen on weekend. So it's like 8:30 to 11:30 Saturday, Sunday, and in 2 weeks, or I think 3, 6, 12, or I think in 2 weeks we will finish this course. Thank you all. I think 15th of August it is starting. 15th of August. What is the prerequisite? Prerequisite is nothing but more to learn something new. Hadoop, Spark. You don't need that for Kafka training, but basically, if I'll take example of Spark or Storm, then you need some understanding if you have already worked on those things. Guys, I'm ending the session. Okay. Hope to see you all in class next week. Thank you all.